Right, so in this video, we're going to talk about solving systems of equations by elimination, okay? And this is just the name of the theory that we're going to use here, okay? We've talked about how to solve a system by graphing, where we're just looking for the lines to intersect, okay? So today we're talking about elimination. So if we're given a system of equations that looks like this, okay? If we wanted to graph them, right, we still could move the 4x's over, divide by whatever it is we're dividing by, okay? And really, we could still graph if we wanted to. However, there's also an easier way, okay? In this case, notice how the x's, the y's, and the whole numbers are all lined up kind of evenly. Okay, that is one clue that you should probably use this setting. Right, so it's really fairly simple. All we're going to do is we want to essentially cancel out a variable. Okay, and what I mean by that is when we add the added together, when we combine or we add together the two equations, okay, we want one of the variables to cancel out. So in this example, it's pretty straightforward, okay, because when we combine them or we add these together, okay, 4x and negative 4x cancels out. Now we're left with 8y plus 2y is 10y. And then 20 and negative 30 would give us a negative 10. So we've essentially canceled out one of the variables. So now we're going to solve for the other. Pretty easy right here. We're just dividing by 10. Okay, so we get y equals to negative 1. And then we're going to take that and solve for the variable we canceled out. Okay, so if y equals negative 1, we're going to plug in negative 1 to either one of these equations. I'm just going to plug it into the top one here. So 4x plus 8 times negative 1 equals 20. 4x minus 8 equals 20. I'm going to add the 8 to the other side. And I get 4x equals 28. And I get x equals 7. Okay, so I get negative 1 and 7. Okay, write it as a point, like so. And so again, if we graph these two lines, if we moved it and we set them equal as y equals and graph them, they should still intersect at 7, negative 1. Okay, this is just a different way to figure out the same answer. Okay. Let's see. Right. This is pretty easy, right? Because we should be able to see the 4x and the negative 4x and know that they're just going to cancel out. It's not always going to be that easy. So like if we had something that looked like this, negative 4x plus 9y equals 9, and then x minus 3y equals negative 6. Okay, if I tried to just combine them right now, okay, nothing would cancel out. So that'd be an issue. Okay, so what we want to do is we want to manipulate one of these equations so that we can have something cancel out. So this is negative 4x. What would this have to be so that the x's would cancel out? Well, it'd have to be a 4x. So if I multiply this whole thing by 4, I get 4x minus 12y equals negative 24. I just multiplied each one of those by 4. Now I have a 4x in front, which I want. I leave the top equation the exact same. Okay, and now I'm kind of right back to where I was at the beginning of the first problem. Okay, because when I combine these, the x's cancel out. I have 3y, and I have negative 15. Divide by 3. Y equals negative 5, so there's one of my answers. I got to plug it back in. Again, I'll just plug it into the top one. Doesn't matter. So I have negative 4x minus 45 equals 9. Add 45 to the other side. Get negative 4x equals 54. Divide by negative 4. X is going to equal, ooh, that doesn't come out nice. That's okay. Negative 27 over 2. Okay. It's possible I did something wrong, but oops. It's off the screen there, sorry. Okay, so again, the negative 5 we plug back into the top equation. Could have plugged it into the second one or even the one we made up. And then we have negative 4x minus 45 equals 9. Add 45 to both sides, so I get negative 4x equals 54. Divide by negative 4 reduces down to negative 27 over 2. All right, and then here's an even more complicated problem here. 2x plus 8y equals 6. Negative 5x minus 20y equals negative 15. Okay, so not only right off the gate does nothing easily cancel out. Okay, I can't really multiply anything on top so that it's the negative opposite of one of the ones on the bottom. Okay, so things like this will take a little bit of practice, and I've got a bunch of worksheets for you to do. So, so the easiest thing to do would be, well, if I want to cancel out the x's, now I'm going to have to multiply both by something. So I'm going to just multiply by the opposite. So I want this 2x, I want to be able to multiply it by 5, and then multiply the bottom by 2, so that now it's going to be 10x and negative 10x. So 2x times 5 is 10x, 8 times 5 would be 40y, and 6 times 5 would equal 30. Now I'm changing the bottom one as well. That gives me negative 10x, negative 40y, and negative 30. Okay, so notice it gets a little crazy here. This cancels out, this cancels out, and this cancels out. Okay, so anytime that happens, really what we ended up with 0 equals 0. And so that means there are infinite solutions, okay, because it's the same line. Okay, and it's easier to think about on a graph is that if you have a line like that and then the exact same line right on top of it, okay, all of those points are the solutions. Okay, if we got something that equals 12 equals 0, Okay, that would mean no solution. And that's because the lines are parallel with different y-intercepts. Okay, so if you had two parallel lines like this, okay, they're never going to intersect. Okay, so there is no solution that fits both of those equations.